523 continuous subarray sum. Given an integer array nums and an integer k, return true if nums has a good subarray or false otherwise. A good subarray is a subarray where its length is at least 2 and the sum of the elements of the subarray is a multiple of k. Note that a subarray is a contiguous part of the array. An integer x is a multiple of k if there exists an integer n such that x equals n times k. 0 is always a multiple of k. Example 1. Input: nums is the array of 23, 2, 4, 6, and 7. K equals to 6. Output: true. Explanation: the array of 2 and 4 is a continuous subarray of size 2 whose elements sum up to 6. Example 2. Input: nums is the array of 23, 2, 6, 4, and 7. K equals to 6. Output: true. Explanation: the array of 23, 2, 6, 4, and 7 is a continuous subarray of size 5 whose elements sum up to 42. 42 is a multiple of 6 because 42 equals 7 times 6 and 7 is an integer. Example 3. Input: nums is the array of 23, 2, 6, 4, and 7. K equals to 13. Output: false. To solve this problem, we can leverage the mathematical property of modular arithmetic. Specifically, we can use the fact that if the sum of elements in two subarrays has the same remainder when divided by k, then the difference between those two sums, which is the sum of the elements in the subarray between the two endpoints, is a multiple of k. Initialization. We initialize a dictionary remainder index with the dictionary of key 0 and values -1. This handles the edge case where the subarray starts from the beginning of the array. Cumulative sum and remainder calculation. As we iterate through the array, we keep a running total, cumulative sum, and compute the remainder of this sum when divided by k. Check for good subarray. If the remainder has been seen before, and the length of the subarray between the previous index and the current index is at least 2, then we have found a good subarray. If the remainder is new, we store it in the dictionary along with the current index. Return result. If we find such a subarray, we return true. If we finish the loop without finding one, we return false. The time complexity of this solution is O of n because we are iterating through the input list of size n once. The space complexity is also O of n because we are storing at most n remainders in the remainder index dictionary.